Students, today we are going to discuss permutations and combinations from class 11. This is an interesting topic, yet sometimes examples tend to be confusing. So watch the video till the end. Some concepts. The fundamental principle of counting, or simply the multiplication principle, states that if an event can occur in m different ways, following which another event can occur in n different ways, then the total number of occurrence of the events in the given order is m into n. Now this above principle can be generalized for any number of finite events. That means if there are 3 events m, n and p in that order, then the total number of occurrence of events would be m into n into p. Now the events could occur in various possible orders, but we have to choose any one of the possible orders and count the number of different ways of the occurrence of the events in this order. That means, like stated above, suppose m occurs and then n occurs, then the total number of occurrence will be m into n. For example, a child has 6 ice cream flavors and 3 cone varieties. The total number of choices will be 6 into 3. Suppose Mark has 15 hotel options, 6 rental car options and 8 flight options. And the total number of possible combinations will be 15 into 6 into 8. Now what do you mean by permutations? A permutation is an arrangement in a definite order of a number of objects taken some or all at a time. The formula: the number of permutations of n different objects taken r at a time, where r is between 0 and n, and the objects do not repeat, is n into n minus 1 into n minus 2 up till n minus r plus 1, which by formula is denoted as nPr is equal to n factorial upon n minus r factorial. First of all, I hope everyone knows what is n factorial. N factorial is n into n minus 1 and so on up till 1. That means, for example, 4 factorial is 4 into 3 into 2 into 1. So, if n objects are there totally and r are taken at a time, then the possible arrangements will be nPr is equal to n factorial upon n minus r factorial. Now, if you are having np0, that will always be 1, and npn by the above formula will be n factorial. Why? Because 0 factorial is considered as 1. For example, if you have a lock where you need to enter 4 digits, then the order matters. That means you can have any number of combinations, but in that order occurs. If I have the code as 8351, then 1538 is different from that. So remember one thing, in permutations, order matters. For example, the number of ways in which a chairman and a vice chairman can be chosen from among a group of 12 persons, assuming that one person cannot hold more than one position, that means a person cannot be both chairman and vice chairman, then it is 12p2, which is equal to 12 factorial upon 10 factorial, or 12 into 11. I think it can be understood why it is so, because for the first place, for example, for the place of the chairman, there are 12 options. So now one person you are selecting from that as the chairman. So now the remaining options are 11. So the possible arrangements can be 12 into 11, which is 132. Results on permutations. The number of permutations of n different objects taken r at a time where repetition is allowed is r raised to n. That means, for example, the number of different 2-letter words formed from the letters A, B and C where repetition is allowed is 3 square, which is 9. Why? Because you know that A and A repetition is allowed. So A, AB, AC, BB, BA, BC, CC, CA and CB. Again, CA and AC are different because why? Remember, in permutation, order is important. Permutations when all the objects are not distinct objects. the number of permutations of n objects where p1 objects are of one kind, p2 of second kind, and so on up till pk are of kth kind, and the rest, if any, are of different kind, then that permutation is given by n factorial upon p1 factorial, p2 factorial up to pk factorial. Let us take an example. Find the number of permutations of the letters of the word Allahabad. Now see, totally there are 9 letters. From that, there are 4 A's, 2 L's, and rest all are different. Therefore, the required number of arrangements will be 9 factorial upon A's. There are 4 A's, so 4 factorial, and there are 2 L's, so it is 2 factorial. So 9 factorial upon 4 factorial into 2 factorial. When we simplify that, we get as 7560. Remember the technique in simplification of factorial. Like I have 9 factorial, down I have 4 factorial. So up till 4 factorial you multiply it. After that 4 factorial will get cancelled. So this is how examples are solved. Let us start with the examples. Find the number of 4-lettered words with or without meaning which can be formed out of the letters of the word rose where the repetition of letters is not allowed. Now see, we have the word which is of 4 alphabets and we have to make the new words which are also of 4 alphabets, and repetition is not allowed. So for the first alphabet you have 4 choices out of R, O, S and E, so it is 4. For the second place, again since the first one is already chosen, there are 3 options remaining. So it is 3, same way 2 and 1. So the total number of possible combinations will be 4 into 3 into 2 into 1, which is 24. Hence the required number of words is 24. Now in the same example, suppose if repetition was allowed, that means you can take R 2 times or anything more than 1 time repetition is allowed, then the first place can be filled in 4 ways. Again for the second place there are 4 possibilities. So you have 4 raised to 4, which is 256. This is like the formula we have just seen, n raised to r. So it is 4 raised to 4, which is 256 if repetition is allowed. Example 2. In how many ways can the letters of the word permutations be arranged if first case the words start with P and end with S? So now for the first case, now total there are 12 alphabets in permutations, in which there are 2 T's and all the 5 vowels A, E, I, O, U occurring once. You have to find the number of words possible which are starting with P and ending with S. So the first and the last position is fixed respectively for P and S. In between there are 10 letters. Now in those 10 letters, 2 are T's. So now according to the formula we have just seen, when there are letters of one type, how will you have n factorial upon p1 factorial, p2 factorial, pk factorial. So over here you are having 10 factorial upon 2 T's are there. So 2 factorial, which is 1814400 possible arrangements. Second case is you have to find the number of words such that there are 5 vowels and they are together. So we consider all the vowels as one group, as one particular thing. And hence the number of permutations of the vowels will be how much? First of all, there are 5 vowels. So in between those 5 vowels, 5 factorial possibilities are there. First you take I, then you take E, first you take E, then you take I. So anything can be taken, any vowel can be taken in any of the places. So for the 5 vowels, there are 5 factorial or 120 possibilities. Now the remaining letters are 12 minus 5, which is 7. In those 7 letters, there are 2 T's. So now how many total distinct, you can say, groups which you are having? They are 7 letters plus 1 group which is of our vowels. So total 8 are there. So n is 8 factorial upon what is the one type of group is there in which there are 2 T's. So you have 2 factorial, similar type of elements. So now that will be 8 factorial upon 2 factorial, which is 20160. So now when we combine both of this, the number of words that can be formed such that vowels are all together will be how much? 20160 into the internal combination. internal permutations of the vowels, which was 120. So 20160 into 120, which is 2419200. Third case, we want that there are always 4 letters between P and S. So now suppose P is there and S is there, in between there are 4 letters. So suppose if P is in the first place, S will be in the 6th place. In between 4 are there, correct? Suppose P is in the 2nd place, then in the 3rd, 4th, 5th, 6th place any other letters, and S in the 7th place. Same with 3 and 8, 4 and 9, 5 and 10, 6 and 11, 7 and 12. So totally for 4 letters being in between P and S, there are 7 ways. But P and S also can be interchanged. That means it is not written that first P comes and then S comes. It can be in any order. Suppose the first one, in the first place P is there, 6th place S is there. It can also happen in the 6th place P is there, in the first place S is there. So that is possible in 2 ways. That means the total possibilities will be 2 into 7, which is 14 ways. Now remaining there are 10 places which can be filled by 10 letters in which there are 2 T's. So that is, as we know, 10 factorial upon 2 factorial. So ultimately the number of words such that there are always 4 letters between P and S will be 1814400 into 14. So that is 25401,600 ways. All the examples are done in different ways, so think before you write the answer. Example 3. Find n if n minus 1p3 is to np4 is equal to 1 is to 9. Now this is simple application of the formula. So now we know the formula for nPr is n factorial upon n minus r factorial. So if we simplify the numerator n minus 1p3, it will be n minus 1 factorial upon n minus 1 minus 3 factorial. Similarly, we simplify the denominator. So now what we have is n minus 1 factorial into n minus 4 factorial upon n minus 4 factorial into n factorial. N minus 4 factorial gets cancelled out. Now see, n factorial can be written as n into n minus 1, n minus 2 and so on. So that is n factorial is n into n minus 1 factorial. Remember, this is the technique in all the examples which we use. So n factorial we are writing as n into n minus 1 factorial. So n minus 1 factorial gets cancelled. It is equal to 1 upon n. And what is the ratio on the right hand side given? 1 is to 9. So 1 upon n is equal to 1 upon 9, which gives n as 9. Next example. In this you have to find r. When it is given 5pr is equal to 2 into 6pr minus 1. So again we apply the formula. nPr is n factorial upon n minus r factorial. So the right hand side will be 2 into 6 factorial upon 6 minus r minus 1 factorial. So you have 5 factorial upon 5 minus r factorial is equal to 2 into 6 into 5 factorial upon 7 minus r factorial. So now again, as I told you, what you do is you bring r on one side. So 7 minus r factorial upon 5 minus r factorial is equal to 12. That is equal to 7 minus r. What is 7 minus r factorial? For factorial you go on subtracting 1. So 7 minus r into 7 minus r minus 1 into 7 minus r minus 2 factorial upon 5 minus r factorial. But what is 7 minus r minus 2 factorial? It is 5 minus r factorial. So 5 minus r factorial gets cancelled out. Ultimately what you have is 7 minus r into 6 minus r is equal to 12. This is a quadratic equation. So you have the quadratic equation r square minus 10r minus 3r plus 30 equal to 0. On simplification you get r as 10 or 3. But we know that for nPr, r should always be less than or equal to n. So possible value, since n is 5, possible value is 3. So the answer is r is equal to 3. Now we will study about combinations. Suppose if we have a group of n objects out of which we make a selection taking r objects at a time, then the number of such selections is given by nCr, which is equal to n factorial upon r factorial into n minus r factorial, where r is between 0 and n. Remember, permutation was for arrangement of objects while combination is for selection of objects. Correct? So now it is very clear from the formulas that as we have nPr as n factorial upon n minus r factorial and nCr as n factorial upon r factorial into n minus r factorial, what is the relation between permutation and combination? nPr is equal to nCr into r factorial. Now n minus r, that is equal to, when we just use the formula for combination, n factorial upon n minus r factorial into n minus r factorial, which on simplification gives nCr. That means, very simple example, suppose if I take phi c3 or if I take phi c2, it will be the same. Why? Because n is phi, and suppose if I am taking say phi c3, so r is 3. So what is n minus r? It is 2. So n minus r will also be same and nCr will also be same. So phi c3 and phi c2 will be same. That is just used in the examples. Another result is, if suppose nCa is same as nCb, that implies that a and b are same. Or you can say a is equal to n minus b. So actually in that case n is equal to a plus b. So basically what you need to remember is just the formula of nCr, which is n factorial upon r factorial into n minus r factorial. This is a small theorem in which we are just using the definition of nCr. nCr plus nCr minus 1 is equal to n plus 1 Cr. So from the left hand side we just put the formula. nCr is n factorial upon r factorial n minus r factorial. Same way, instead of r, if you have r minus 1, you have n factorial r minus 1 factorial n minus r minus 1, that is n minus r plus 1 factorial. So now after simplification of what do you have? N factorial r factorial can be written as r into r minus 1 factorial, and same way the second term. So now when we take the LCM and we take out common, n factorial upon r minus 1 factorial into n minus r factorial. In the bracket you have 1 upon r plus 1 upon n minus r plus 1. After simplification, what do you get? In the numerator you get n factorial into n plus 1. So what is that? N plus 1 factorial. I think it is very clear. N plus 1 factorial is n plus 1 into n factorial. Like you have 5 factorial is 5 into 4 factorial. Correct? Same way. And in the denominator you have r minus 1 factorial, n minus r factorial. So into r into n minus r plus 1. So that can be written as r factorial into n minus r plus 1 factorial after simplification. So what is that? That is equal to the right hand side n plus 1 Cr. So this is just by the use of formula. Now since we have done two things, let us see what is the difference between permutations and combination. First thing is why it is used. Permutation is used for arranging objects and combination is used for selecting objects. That means, for example, you are having a rack of books. Then if you want to arrange the books, you use permutation. In different orders you want to arrange the books. But you just want to select some books out of that, you use combination. Correct? Second thing, in permutation order is important. As I told you, suppose you are having the winners, say first place, second place, third place. Then the place is important. Correct? Order is important. While in combination, order is not important. Same example, for picking up the first, second and third place winners, permutation can be used, while combination is used just to select the 3 winners from a group of participants. Another example, suppose for arranging numbers, alphabets, books, etc., permutation is used, while combination is generally used to select articles, clothes, items. Say you want to select some items from the menu. In that order doesn't matter whether you take item first or you take item second. Just you are selecting the items from the menu. So in that case, combination is used. Permutation is used for arrangement. Combination is used for selecting. Example 5. What is the number of ways of choosing 4 cards from a pack of 52 playing cards? And then some other cases are asked. The first thing is though, there will be as many ways of choosing 4 cards from 52 cards as there are combination of 52 different things taken 4 at a time. You are just selecting any 4 cards from 52 cards. So that is possible in 52C4 ways. nCr, n factorial upon r factorial, n minus r factorial. So numerator 52 factorial, denominator 4 factorial into 52 minus 4, that means 48 factorial. Simplify this. How will you simplify? 52 factorial is 52 into 51 into 50 into 49 into 48 factorial. So 48 factorial will get cancelled out. So these are 270725 ways. Now the first case is the 4 cards which you are selecting, they should be of the same suit. That means if they are diamonds, all the 4 should be diamonds. If there are clubs, all the 4 should be clubs, and so on. You know there are totally 4 suits: diamond, club, heart and spade. So each of them has 13 cards. So out of 13 you are selecting 4. Suppose you are selecting 4 diamonds, it is 13C4 for diamonds. Same way you have for other 4 suits. So totally how many possibilities are there? 4 into 13C4, which on simplification will give you 2860 ways. Second case is the 4 cards should belong to 4 different suits. That means one should be diamond, one should be spade, one should be heart and one should be club. Each of them are 13 type. Each type has 13 cards. So what are the number of ways? 13C1 into 13C1 into 13C1 into 13C1, which is 13 raised to 4 or 28561 ways. Third case is all are face cards. You know that there are 3 type of face cards. You have jack, king and queen. But all of them are there for all the 4 suits. So totally how many face cards are there? 4 into 3, 12. So number of ways of selecting 4 cards out of those 12 will be 12C4. 12 factorial upon 4 factorial into 12 minus 4, which is 8 factorial. So when you simplify this, 12 factorial is 12 into 11 into 10 into 9 into 8 factorial. 8 factorial gets cancelled out. So you have totally 495 ways. Fourth case. The 4 cards which you are selecting, in that the 2 are red cards and 2 are black cards. What does this mean? 2 red cards means totally you are having the diamond and heart, both are of red color. So totally you are having 26 red cards. Similarly, you are having 26 black cards. So 2 red and 2 black means 20C2 into 20C2. So when you simplify that, again I am telling you, be careful in the simplification. 26C2 means 26 into 25 into 24 factorial upon 2 factorial, 24 factorial. So 24 factorial will get cancelled out. So ultimately it is 325 square or 105625 ways. Fifth case, all the cards are of same color means either all are red or all are black. Same color means either they are red or they are black. So now remember, over here either they are red or they are black. Either means if all the 4 are red, then all the 4 cannot be black. Correct? So you have plus in between. Now this is very important. Don't get confused in the fourth and the fifth case. In the fourth case, you need 2 red and 2 black cards. So it is multiplication sign in between. This is a tip which you can remember. So if you are having and, it is multiplication in between because the events are independent. But if you are having or, you will have addition in between, as the events will be mutually exclusive. Means if suppose all the cards are of black, then they cannot be of red. So you are having plus sign. Or means plus and means multiplication. So if you remember this, confusion will not be there. So in the fifth case, the total number of ways are 29900. Example 6. Now this is simple use of the formula. Determine n if 2nC3 is to nC3 is equal to 12 is to 1. So now just apply the formula. You know nCr is n factorial upon r factorial n minus r factorial. So numerator and denominator you simplify. After simplification, what do you get? Ultimately you are getting 4 into 2n minus 1 upon n minus 2 is equal to 12 is to 1 means 12 upon 1. So 2n minus 1 is equal to 3 into n minus 2, which on simplification gives n is equal to 5. Be careful in the simplification. Example 7. How many words with or without meaning each of 2 vowels and 3 consonants can be formed from the letters of the word daughter? Now see over here, you are having 3 vowels and 5 consonants. In the word daughter, you are having totally A, U and E. There are 3 vowels and other 5 are consonants. So the number of ways of choosing 2 vowels and 5 consonants will be 3C2 into 5C3, and that means you are having multiplication sign in between. So simplify 3C2 into 5C3, you get 30. Now each of these 5 letters can be arranged in 5 factorial ways. That means 5p 5 ways. Hence the total number of words, when you're forming words, remember first thing is you select the words and after that you arrange them. So arrangement will be also important over here. So this example you are using combination and permutation, both the things actually. So each of the 5 letters can be arranged in 5 factorial ways. Hence the number of words each of 2 vowels and 3 consonants will be how many? 30. First you are selecting the words and then arrangement. So 30 into 5 factorial, which is 30 into 120 or 3600 possibilities. Example 8. See, each example is of different kinds. So you have to think and answer the question. If the different permutations of all the letters of the word examination are listed as in a dictionary, how many words are there in this list before the first word starting with E? So now try to understand this. First thing is it is a dictionary order. That means first A, then B, in this order it comes. Correct? So now what do you want? How many words are there in this list before the first word starting with E? So now examination, this alphabets, if I arrange it in dictionary order, it will be A, E, I, M, N, N, O, T, X. Correct? The words before the word starting with E means they can start with A. Correct? So actually you are having the word starting with A. For the remaining things, there are 2 I's and 2 N's. That also is clear. So first position is fixed with A. Now remaining there are 10 places and that can be filled by 10 factorial upon 2 factorial into 2 factorial. Why? Because 2 I's and 2 N's are there. So it is of that kind. N factorial upon P1 factorial, P2 factorial. Correct? So this is 907200 number of ways. These are the number of ways for the words starting with A. Example 9. This kind of examples are also asked. In an examination, a question paper consists of 12 questions divided into 2 parts, part 1 and part 2, containing 5 and 7 questions respectively. That means part 1 consists of 5 questions, part 2 consists of 7 questions. A student is required to attempt 8 questions in all, selecting at least 3 from each part. In how many ways can a student select the question? Have you ever imagined this many possibilities are there? Selecting at least 3 questions from each part means at most 5 questions. Correct? The possibilities are, first case is part 1, it has 5 questions. So 3 questions out of 5 in part 1. And then how many totally you have to select 8. That means from part 2 you have to select the remaining 5. Suppose you are selecting 4 from part 1, then 4 from part 2. And suppose you are selecting 5 from part 1, then 3 from part 2. Totally there are 8. Correct? And at least 3 from each part. So number of ways in the first case. First case is 3 questions from part 1. That means totally 5 are there, from that 3. So 5C3 into, and so into 5 questions from part 2. 7 are there in part 2. So 7C5. So 5C3 into 7C5, on simplification it is 210. Second case, the number of ways, 4 from part 1, 4 from part 2. So 5C4 into 7C4, which is 175. Third case, 5 questions from part 1 and remaining 3 from part 2. So 5C5 into 7C3, which is 35. So now the questions can be selected in totally any of the three possibilities is possible. If first case happens, second will not happen, correct? So either of these three possibilities are there. So it is 210 plus 175 plus 35, which is 420 number of ways. Example 10. This is a different type of example. It is called circular permutation. What is circular permutation? First of all, the first case is, suppose there are 5 different precious stones which you want to arrange in the form of a necklace. Necklace means circular. How many possible arrangements are there? Now see, if the clockwise, what is the rule? If the clockwise and anti-clockwise arrangements are different, then the possible arrangements in the circular fashion are n minus 1 factorial. Now remember, there are 5 different stones. Suppose there are ruby, there are emeralds, there are diamonds, then first ruby can come, then emerald can come, and in that order clockwise. Same thing you can arrange anti-clockwise also. So that will be considered different. So if they are considered different, then total number of arrangements are n minus 1 factorial. So possible arrangement in this case will be 4 factorial or 24. The second case rule is, let there be 5 diamonds which are to be arranged in the form of a necklace. Now how many possible arrangements are there? In this case, all the 5 are diamonds, same type. So whether the first diamond comes first or the second comes first, it will look the same. So if clockwise and anti-clockwise arrangements are considered the same, then the possible arrangement will be n minus 1 factorial by 2. So in this case, it will be 24 by 2 or 12 possible arrangements. Maybe this type of example can be asked in objective. We have discussed in detail the concepts of permutation and combination with the help of different types of examples, and each example you have to think before you apply the formula. So please practice the examples. Do like and share the video and subscribe to the channel. Thank you.